Example 1. Claim. Most consumers uncomfortable with drone deliveries. Confidence interval method. 1,009 consumers were asked if they were comfortable with having drones deliver their purchases, and 545 of them responded with no. Use these results to test the claim that most consumers are uncomfortable with drone deliveries, and we interpret most to mean more than half or greater than 0.5. So recall about the confidence interval method. Because a confidence interval estimate of a population parameter contains the likely values of that parameter, you reject the claim that the population parameter has a value that is not included in the confidence interval. So for confidence level for confidence intervals, the significance level for the hypothesis test. For 0.01, the two-tailed test is 99%. For a one-tailed test, it's 98%. For 0.05, the two-tailed test is 95%. For a one-tailed test, it's 90%. For 0.10, the two-tailed test is 90%, and the one-tailed test is 80%. So, first we want to be able to determine the claim and the opposite of the claim. Okay, so let's take a look here. So we know that the claim is that P is greater than 0.5, and the opposite would then be less than or equal to 0.5. So recall that the null always has the equality. So we would then say that this is going to be in the null hypothesis, and therefore P is going to equal 0.05 because the equal sign is in the opposite of the claim. And therefore, the claim P is greater than 0.5 is then going to be in the alternative. Okay, now the next thing that we want to know is the following. We want to determine whether this is a right tail, left tail, or two-tailed. Well, since it says greater than, we know this is a left tail. And because this is a left tail, that means it's a one-tail test. And then number 3, we know that the significance level isn't given, and since it's not given, then it's going to be 0.05. So that tells us the following. Okay, so if we take a look here, since it's a one-tail and the significance level is 0.05, so there's 0.05, it's a one-tail test, so we're going to be using the 90% confidence interval. So the claim again, the majority of consumers are not comfortable with drone deliveries, can be tested with a 0.05 significance level by constructing a 90% confidence interval. So now in step 2, we're going to find the margin of error E that corresponds to a 90% confidence interval. So recall that for the confidence level alpha and the critical Z value, these are our main ones that we use. So since we're using a 90% confidence level, that means alpha is 0.10, so the critical value is going to be 1.645. So now we can find the margin of error using the formula in 7.1. So what do we know? We know that the critical value now is 1.45. We know that the point estimate, if we write this as a decimal, is 0.540139. Okay, and we know that the complement of that is going to be 1 minus 0.540139, which gives us 0.459861, and then the value of the sample size is 1009. So in this case here, we want to make sure that we find that decimal equivalent, since we're going to be doing this by hand here. So now we're going to plug this into our formula. So we know that the critical value is 1.645, and then we're going to multiply that by the square root of the point estimate of 0.540139 times its complement, and then we're going to divide that by the sample size, which is 1009. So let's go ahead and do that on our calculator to verify our solution. So the best thing to do here is first start with the square root value. So we're going to go parentheses 0.540139, and then we're going to multiply that by 0.459861, and then we're going to press enter, and then we're going to divide that result by 1009. Now that is our answer, so we need to take the square root of that answer. So second square root of the answer, and that gives us this value. And now we want to multiply it by the critical value. So we're going to multiply that by 1.645, and therefore that gives us, rounded to 6 decimal places, 0.025810. So that represents the margin of error. Okay, now since the 90% confidence interval estimate of the population proportion, we want to find that. So constructing the confidence interval is easy now that we know that the point estimate is 0.540139 and the margin of error is 0.025810. So we know that the formula for that is the point estimate minus the margin of error and the point estimate plus the margin of error. So here we have 0.540139 minus 0.025810. So again, there is our point estimate. So we know that that's listed there. And then we have the margin of error, which is 0.025810. So we're subtracting it and adding it on both sides. So when we subtract those two, we get 0.514329. When we add those two values, we get 0.56949. And then rounding it to 3 decimal places, we get 0.514 and 0.566. So we're saying that the population proportion must be in between those two values. So if we come back and we need to look at the claim. Okay, the claim tells us that we want to make sure to interpret that most, which means that it's greater than 0.5. This is our claim. So we want to make sure that this most of greater than 0.5 falls in this range of values. Well, we can see that the entire range of values in this confidence interval is greater than 0.5 because it's starting at 0.51 and it ends at 0.56. So we can say that we are 90% confident that the limits of 0.514 and 0.566 contain the true value of P. So the sample data appear to support the claim that more than 0.5 consumers are comfortable with drone deliveries.